This is IO 203, preparing and operating for Black Friday. This is a conversation about how different companies go through Black Friday preparations and some of the experiences Google has had helping those customers. To try and level set a little bit, what we're going to talk about is some of the differences in behavior of a Black Friday and why, as we go through this, you'll sort of understand why it takes a lot of extra planning and preparation. So Black Friday events are usually defined by extreme peaks in volume, so having 5x up to 20x of normal load, so a dramatic increase in the amount of queries per second that you have. Also, requiring fast scaling in often cases. So you will have situations where at a particular moment in time, 6 a.m., 8 a.m., et cetera, that certain things start to happen involving a Black Friday that suddenly causes a fast spike as well. So you have to have systems that respond to that dramatic scale very quickly. And then the last element of a Black Friday that's pretty important is the perceived performance needs. Users expect your systems to operate just like they did several days earlier, and not being responsive means that people are going to alternative means to collect the information or buy the goods that they're after. So having a plan, this is a pretty straightforward type of thing. We're going to walk through 3 different stages: planning for Black Friday, preparing and setting up systems that take some time to evaluate and make sure you're successful, and then executing on Black Friday itself, which it shouldn't be a surprise, but hopefully the execution stage is actually not terribly exciting, which is our goal. So as I go through this, I want to do some architectural design patterns as well. So I want to introduce early in the process sort of a general retail architecture of a system where users come in through a content delivery network. The content delivery network is providing some caching and some capabilities for scaling, which then hands off the workload to the customer's front-end web servers. Those web servers work with multiple different APIs, each of those APIs having some distinct characteristics about them. And then also, in this particular architecture, using an interconnect to get back to on-premises for maybe inventory checks, pricing checks, and submission of orders. So I want to keep this in mind because I will cover this on a couple of slides as we go through some architectural design patterns and things that can help with Black Friday. So the first stage, the planning stage, involves a couple of core areas: data collection, setting shared objectives, and then trying to work through some architecture patterns of things that you can do to prepare your systems. On the planning stage, there shouldn't be anything that's terribly surprising here, but having a plan, going through these steps in a rigorous fashion can help you be successful. You want to review the data you have and collect the data you need. You want to work out your SLIs and SLOs. SLIs are service level indicators. These are the indicators of what the users are experiencing. SLOs are service level objectives, what you want to achieve with those objectives. Now, you may have regular SLIs and SLOs for the rest of the year. You also want to plan for what your expectations are if they are different during Black Friday. So you may ease up on things like latency requirements because you know the traffic is going to be so intense. You may not be able to meet the same quality of service that you do on other parts of the year, but you still want to have agreement on your expectations. You also want to take into account the forecasting of the business analysis against the SLIs. So take into account how much sales is expecting, how much traffic they're hoping to accomplish, what the difference is between this year and last year, and translate those into SLI expectations that can help you set your SLOs. Next, you really want to make sure that you get buy-in very early from all the different groups that are involved in Black Friday. So while Black Friday operations falls to your operations team to try and keep things up and running, without support from engineering, without support from the business unit and what they're trying to accomplish, without executive alignment, a lot of this becomes very challenging during the event to try and make all of these parties happy. So you want to try and make sure They're all involved early, they all have buy-in, they're all being represented as stakeholders, and they understand how you're moving forward. You want to review your existing monitoring capabilities. So you have your SLIs and SLOs, but you need to review how are you presenting that data? What data are you able to present? Are you able to get multiple groups to agree to analyze the system on one dashboard, or do you need business-specific dashboards? So the business unit may not be interested, for example, in queries per second. They may be interested in something like dollars per hour that they want to see. So understanding what you can and can't accomplish at monitoring gives you an idea of what you need to build in the preparation stage. And next, starting very, very early in the process, you want to talk about capacity planning and exercises around capacity planning. So being able to do physical, logical, and cloud capacity planning. How much disk do you need? How much CPU? You also want to look at what APIs and dependent services you're looking at, and what are the quotas and capabilities of those services. And then lastly on this one, you want to start to develop checklists. Now, there's a lot of debate in the industry about things like checklists, but I think we're all a lot happier when we jump on an airplane and a very well-trained professional pilot goes through a checklist to make sure everything works on that airplane. We're not necessarily repeating this as often as they do, but the idea is that having checklists even helps out professionals like airplane pilots be able to be successful. We want to do the same thing with our operations team, give them the opportunity to be successful and walk through an agreed upon set of steps to make sure that they're ready and able to handle Black Friday. So after that, or during that, as you're planning, you start to look at some of the architecture patterns that you can apply to your system. Patterns that help you, not necessarily functionally, but help you at scale, help you at being able to handle peak load. There's several that I'm going to cover. I'm going to cover a few in the planning stage and then a few in the preparation stage. And it's just important to look at the different patterns that are available, and some of them that I'm showing here, to determine which ones are within your ability to influence on your system before the big event. So looking into a couple of the patterns here, one of the more important patterns is a queuing strategy. Having a queuing system protect some of your APIs. The intent here is to do some decoupling of systems and not necessarily have direct dependencies of a consumer and a provider. By putting a queue in the middle, it gives you an opportunity to protect that, that provider. It gives you an opportunity that in this example, for example, this one, to be able to protect the back-end systems from being overloaded. They may have a fixed amount of capacity, a fixed amount of processing that they can accomplish. Having a queue in front of that will protect those APIs and those back-end systems from being overwhelmed. It also gives you some opportunities to do some tuning and managing on the queue and trying to do some processing and figuring out if your queue starts to become overloaded, what do you actually want to do with those long-running requests? Another pattern, very popular, is being able to leverage caching. Now, caching means a lot of things to a lot of different people, and I show three different examples here. At the content delivery network layer, we're storing content, so fragments of HTML, and we're trying to push those out on a CDN to get those close to the end user. This is a very common use case for a lot of commercial sites. Nothing terribly odd about that, but there are some other cachings that are capable as well. Often overlooked and not as often overlooked is the ability to do data caching. So for example, in this scenario, I have a catalog server API, and what I want to do is I want to cache the data that's coming back, but not necessarily the rendering of that data. The catalog does not change very often, so it actually is helpful if I hold that in cache and don't have to call the back-end systems and do the processing to pull that data. Exact same thing with the inventory API here, where maybe it's okay for our use cases and for our users to only query live inventory every few minutes rather than on every single request for a product. The third type of caching I show here is actually within the API itself, using something like Cloud Memory Store within a particular API, in this case, the shopping cart service, and leveraging it something like an in-memory database, which can be used as a cache and as a database to try and optimize and speed up services. Because shopping carts tend to be pretty transient, this is a good use case for using in-memory cache capabilities. Now, the other scenario, sort of an anti-pattern here, which is really important as you think about Black Fridays, is what happens if your cache dies? There are a lot of companies out there that have sort of made some mistakes that they will use the cache to protect their systems from becoming overloaded. But if your cache were suddenly to drop, that would create a huge amount of traffic against your back-end system. You may not be able to handle that traffic, and you created an accidental dependency of leveraging the cache to survive, and during peak, if those caches collapse, you may actually cause a cascading failure through the rest of your system, which makes it 10 times worse than if you had no caching, because you're not really expecting that sort of failure behavior. So this is a bit of an anti-pattern of just being careful not to implicitly build in your system that cache is what's going to allow you to survive Black Friday. Rolling up the planning stage. The deliverables here are making sure that you have a risk analysis from multiple different factors. Technical risk, business risk, operational risk, and making sure you have a plan to address those. Having an idea of what architectural changes your team can take on and accomplish within the time frame that's available. Having a testing plan to move into the preparation stage. Making sure that everyone is on the same page with a communication plan. And then having an agreed monitoring and checklist process and starting to work on operational playbooks that allow you to optimize how to recover from issues as quick as possible. And I'll cover a little bit more of that in the execution stage. So stage 2 is the preparation stage. This is where we want to spend 1 to 3 months before Black Friday. After we've done our planning, we're going into a process of trying to accomplish some work, specifically around being available for Black Friday. We're not really trying to focus on new feature development. We're really trying to focus on resiliency of our systems here. And at this stage, we have 4 core things that we take a look at. Reliability of the system, making sure the monitoring and logging systems are set up, your operations and support systems are available, they've been tested out, they're ready to go into the execution phase and execute flawlessly, and then capacity planning, actually finishing and having agreed upon capacity not only with your own systems, but with the vendors you're working with also. On the preparation stage, in reliability, we have load testing and failure testing. I think you can probably look up talks from Googlers on both of these topics that can last hours on end. In this particular case, I just want to stress the emphasis of doing lots of load testing in a regular, regimented process. You want to be able to develop for a Black Friday the ability to load test 1, 2, 3 times a week and analyze as your engineers are making modifications to the system, what is the impact to the load tests? What is getting better? What is becoming stressed because another part of the system has improved is really important. Working with customers on Black Friday last year, this was a really successful thing over the couple of months preparing, of being able to consistently show back to various engineering teams that one engineering team may have made an improvement, but it actually showed a flaw to another engineering team that then had to change their focus. The other half of this is failure testing, and I think a lot of us don't necessarily want to think about this because we want to believe our systems are going to stay up. They're not going to fail, but the reality is things like cache misses, things like zones not being available or regions not being available are real, actual things. So part of our time while we're doing load testing should be also in intentionally causing at a peak capacity failures and understanding how the system reacts when those failures happen. So in the case of the cache failure I mentioned before, it would be great, maybe not every week, but to test that scenario a couple of times before Black Friday and ensure what is the actual behavior that happens when the caches fail and how do you want to respond to that. Now, in particular to load testing and failure testing, I have two other patterns that are a little bit more complex in implementing, and I'm only scratching the surface here. But the first one is load shedding. Load shedding is the idea that I can only handle a certain amount of traffic, and I have to eventually just acknowledge I'm not going to respond to 100% of requests. At some point, it's good to have an intelligent system that can go in and decide which things are most important, which things are not most important, and try to actually survive by dropping a percentage of my traffic and just acknowledging that maybe I'm not running at full speed, but I'm trying to keep my systems alive and running as opposed to completely falling over. Now, there's two general patterns for doing load shedding. One is having a controller-oriented strategy here, which is where I show the load management at the web servers tier. There are software implementations like Hystrix, which is open source from Netflix, which is a library that helps you do this at the controller level and sort of build your systems to be able to have that load shedding ability. The other part of it is at the individual API level, having some kind of handler or aspect at the front of the service that will prevent a certain amount, will allow you to control and manage that traffic coming into the service and provide that load shedding ability maybe on an API by API level. The other pattern, which is very closely related, is a circuit breaker pattern. The circuit breaker is a very valuable pattern for Black Fridays because instead of trying to drop a percentage of traffic, we're more focused on maybe dropping an amount of functionality entirely to be able to survive. So in this particular example, my system is under load. I know I can't handle every single request. I've intentionally chosen to say I can't provide real-time inventory to my customer. I'm going to actually have code, logic, a build flag or something that says, don't try to run real-time inventory during Black Friday. I'll tell the user, I'll check the inventory when you submit the order, but I'm not going to check it in the middle of it because my system is under stress. Other examples of things that tend to have circuit breakers built in are sort of secondary value adds like user content, like user reviews and things like that, where if we were under normal load and we had the capacity to handle it, these are great value adds, but they're not necessarily critical to the core user journey of, say, purchasing a product. So I want to drop some of these add-on capabilities to make sure that I can keep my purchasing process up and running. Moving on through the preparation stage, there's still a couple other things I wanted to cover here. Having your monitoring and logging system set up. One of the reasons why I showed sort of a falling tree here is if you don't have a monitor or a log for something, you really have no idea whether it happened. So it falls back to that old tree in the forest adage. Having the right monitoring, having the monitoring that tells you how your system is acting is very important. Having a single pane of glass that everyone can agree on the SLIs that are important, and having all of the engineers, all of the operations people be able to see a single pane of glass avoids a lot of I saw A but you see B kind of problem as you're taking a look into issues. The other element of monitoring that's very important to make sure you consider is aggregated reports that provide drill down. So having an aggregated high-level report but being able to get to the details during the execution phase is very important in monitoring. And then the other core area on monitoring that's very important is audit logging. Understanding who modified what parts of the system, especially as you're in the middle of Black Friday operations. You want to make sure, did someone do an accidental code push? Did someone make a configuration change to the system and that's what's causing an issue? Having the audit logging really locked down and understanding who can modify the systems helps with problem resolution. Preparation stage, operations and support. This is where we want to work on setting up operations for success. We want to have communication systems that allow your operations team to work with all your stakeholders. You want to work with a concept that Google has sort of promoted called the wheel of misfortune. This idea is that you get your operations team around a table and you run a simulated error against it. The network connectivity is down, your database is down, you lose 1/3 of your web servers. What would you actually accomplish to try and bring your systems back up? And do it in a process that gives your operations team confidence that when it happens in real time, they can respond fast, they can understand who they have to interact with and how to try and accomplish recovery. Also important to that process, and I think a lot of people fail to bring this into play, is making sure your vendors are also integrated in that process. So working with Google, working with your firewall providers, working with, if you have on-premise router providers, that not that they're necessarily tied into, let's say, your ServiceNow system, but you have a means through your experiences of when to escalate to your vendors, when to make sure that your vendors join your operational success is really important also. Capacity planning again comes up at the preparation stage. This is where you're reviewing what your capacity is across several different dimensions. You want to understand your total capacity. You want to understand how much capacity you have in a region, how much capacity you have in a zone. You also want to look at APIs that you're leveraging or managed services and understand what are the quotas or capacities that you're allowed to accomplish on that. If you're using something like Cloud Spanner or Google BigQuery, you're not running the infrastructure, so you don't have to request CPUs, but you do have to make sure that when you hit peak execution, that those APIs are going to stand up and continue to operate at the velocity that you're asking those services to be operating at. Finally, on the preparation stage, you have your deliverables. You're modifying your documents from your planning stage. You have your testing results and you're reviewing the insights. You have your monitoring system set up. Everyone is happy with where monitoring is going. The ops team feels really comfortable that they can handle a lot of the known types of issues that may happen. They also have some processes in place for how to do triage and troubleshooting. You've worked with your internal teams and your cloud provider to work on capacity, and everyone seems pretty happy to want to get to the execution phase. And this is where it, fingers crossed, gets absolutely completely boring, right? We want nothing to happen at this stage. We want everything to just scale up and run without having any kind of interesting activity. But having said that, there's still some steps we want to do because we want to prepare for the potential incidents that may happen, and we want to make sure that we can ensure that this is as boring as possible. In the execution stage, we want to worry about how we actually scale to peak on our production system. We want to make sure that we have good, solid communication systems, and we want to have some processes to capture this entire execution plan that we've gone through. So for scaling, you want to have a thoughtful strategy on how to scale. Systems doing a big, gigantic jump like the visualization shows here, automatic scaling systems may not scale fast enough. Manual scaling systems may require you to go in and tweak configurations. For example, adding nodes to a Cassandra cluster, you may want to do that manually and make sure that you have Cassandra capability rather than relying on an autoscaler. In theory, all of this should have been tested at the load testing stage. One of the important elements in the load testing is scaling up to peak and scaling back down from peak and making sure that everything runs correctly. Obviously, at the execution stage, you're doing it for real, and now you have to make sure that it happens correctly. For the ops team to be successful, war rooms have been shown to be pretty successful. Having an actual war room can sometimes be tough. A lot of companies now have very distributed operations. You may have ops people in Europe, Asia, and multiple locations in the US. So rather than relying on a physical location, having some kind of virtual collaboration capability allows them to still be where they're at, but be efficient in their collaborations. As they're working on things, and let's say an issue comes up, the thing you want your operations team to focus on is recovery over analysis. I think a lot of ops people want to look at something that's happening and go, I wonder why it's happening the way it is. Let's collect a bunch of data and understand why it happened. If you're in the middle of Black Friday, a huge percentage of your company's revenue may be relying on these few days of operation. It's far more important to get the data collection and recover as opposed to spending a lot of time trying to understand why it's broke in the middle of it being broke. So having your operations teams focus on trying to get to recovery is a critical change in focus. You also want to have an ability then, as an issue or an incident comes up, as different kinds of things pop up, to have an ability to shard off little sub-team workspaces. For a lot of operations, you may have 50, 80, 100 people involved. It's also valuable to make sure that they can get into small groups and try to work on individual things as we're going through the execution phase. And lastly, very importantly, I think a lot of companies don't necessarily take this into account as well, is we really want this to be a no superhero situation. You want to have a team that's well prepped. You want to have a staffing schedule that accounts for the fact that this is 24/7 operations. You want to make sure you have handoff processes so that people that are working on an issue and their shift comes to the end, that sure, it may take a little bit of time to transition, but they can give the responsibility to someone else and go get rested for their next shift of trying to operate the systems. All right, and then fingers crossed, we've gotten through a lot of the execution stage, and now it's important to be able to capture the experience and get ready for the next one. So we want to do a retrospective process. Google calls them blameless postmortems. It's a process where we focus on what worked and what do we need to improve. We ask a lot of how questions, not a lot of why questions. One of Google's core tenets in trying to be SRE focused over this idea of operations is we presume the human tried to do the best they could. If something goes wrong, it must have been the process that caused some of that challenge. So how can we improve the process to make sure the human can do a better analysis and hit the right buttons better the next time? And that's what we focus on with a postmortem is, how do we make sure the next execution goes even better than today's execution? As we're coming out of the execution stage, we need to take some care. We have had some customers in the past that have tried to scale down a little too fast and actually caused themselves an incident because they took too much capacity offline too fast. It's valuable to go back through the entire cross-functional team and understand who was successful where, acknowledge the stress and challenge that this process taking 3, 4, 5, 6 months is, and making sure that everyone understands what the contributions were across the team, making sure that everyone gets an opportunity to de-stress and enjoy the fact that you made it through a Black Friday, hopefully without a single incident, but if you had an incident, you recovered from it very fast. All right, so with that, this is sort of the abstract part of the process. I tried to walk through a general process. Now I want to bring Ron up on stage, and I will let Ron introduce himself. He has experiences from the field of going through this process with him being a member of a customer of Google's.
Carl, thank you very much for the introduction. My name is Ron Curley, and I think it's probably a little overwhelming at first to think about all of that smushed into 30 minutes. And you're probably thinking about your own preparation for a Black Friday type event and going, holy crap, right? Anyway, let me give you a quick rundown of what it is that I do for Target, how I see the world, and then we'll move in a little bit about what my team and I do and how we prepare for Black Friday. So I am previously one of the engineers and currently one of the managers for a team inside of Target responsible for bringing a consistent and ubiquitous infrastructure experience to engineers at Target. What that means is that I'm essentially responsible for building products or services with simple contracts for engineers that such that they can consume infrastructure without actually having to think about where it's running, right? Ultimately, this ends up enabling application engineers to focus on providing rapid business value. And important to us is it allows infrastructure engineers to experiment with, make changes with everything that that workload is running on without introducing problems upstream. So almost all of my current customers are Target.com engineers. And it's critical. What that means is that it's absolutely critical for my team to provide stable, resilient, and scalable services for those teams. My customers are at the very center of the success or failure of a Black Friday type event, and that means so am I. So how do we prepare? For the next 15 minutes or so, I am going to share some of Target's critical learnings with you, and where I can, share some stories to actually highlight how we learned that, why that was important, et cetera. Now, Carl's slides are extremely exhaustive insofar as I could probably identify 2, 3, 7, a dozen war stories about why each one of those bullet points are on those slides. And I would love to share some specifics with you about Target.com architecture or any of our specific challenges, but I can't because of time and lawyers. So, pardon me, and I'm sorry if that was what you were here for. So I've generalized where I can, but I'm trying to keep the point of the story alive. You can't prepare for Black Friday without some sort of prediction about what to expect. And the biggest question you have to ask yourself is what metric are you basing that prediction on? Because when it comes to Target.com, for example, we have a lot of metrics. We've got requests per second, we've got transactions per second, we've got orders per hour, year-over-year growth, cart size, et cetera, front door requests per second, whatever. And the applications that run Target.com are changing on a daily basis, sometimes as rapidly as a dozen times per day. So with constant changes in the architecture, when we make predictions about what Black Friday traffic is going to look like, as Carl pointed out, it's super important to identify the correct metrics to be tracking and to align on a business level objective. Ask yourself if it really makes sense to compare front door requests per second to an application like this from one year to the next, especially if the underlying architecture is changing majorly 5 times a year, 6 times a year, minorly a dozen times a day. That's not really fair to compare that. You might actually be measuring, in that respect, a marketing increase. You might actually be measuring a brand response, the introduction of a new brand. A 300% increase in front door traffic means diddly unless you're also selling socks, right? Big sites with a lot of volume have a lot of moving parts. So just try to remember that the business metrics are always the correct metrics when it comes right down to it. They're the ones that you want to influence. So what are Target's business metrics? At the end of the day, what we really care about is the act of selling socks. There's really nothing interesting going to happen up here. It's all good, fellows, right? Thank you for introducing a new brand. Good fellow. All right, never mind. What we care about is selling socks. How many we're selling, how rapidly we're selling them, how much we're selling them for. And the $10,000 question is how many socks are we expecting to sell? And one of the biggest indicators for that is orders per hour. For a retailer, there are really only 2 seasons. There's peak season and not peak season. Everything that happens during peak season, including Black Friday, Cyber Monday, Thanksgiving, etc., is always in the back of your head. But there has to come a time when you physically start preparing for and planning for the next peak season, starting with the alignment on expectations. Right now, today, last week, the week before, business analysts at Target are already crunching the numbers to try and figure out what those predictions are going to look like. And they will eventually come up with something like, We expect to see 5 times more orders per hour during our peak hour on Cyber Monday. Now, that is not an insider tip. That is an example. Don't go trading on that particular thing. I have no clue what it is. But it all comes back to the business level objectives. If you don't know what they are, you can't prepare for them, you don't know what knobs to turn within your system. Now we're aligned. We're aligned on our business objectives, great. We need to know our current architecture capabilities. How's it performing? How much more can it handle? And that requires at least a basic understanding of the individual services that end up making up the entire system, right? Now, for all of the forward-thinking and cutting-edge technology that Target uses, frequently we're making changes so quickly that it is sometimes hard to know with certainty exactly how a service is performing. So one of the things my team tries to do is provide a standard for them. We try to provide templates that allow all of our engineers to have the basics at their fingertips. For example, I would love for all of my customers to be able to say something along the lines of, and I wrote this down on purpose, we're currently running at 2,000 requests per second during peak daytime load when the total system is processing 1,000 orders per hour, and we know that we can scale to handle a max of 3 times more volume. Real numbers change to protect the innocent, of course, but I want all of my engineers and all of my customers to be able to say something exactly like that. My customers are well tuned to their metrics, but no one's perfect. I mean, I'm not even sure that I could say all of those details about the services that I offer them, although I try to. What we do know with certainty is that without the baselines for those services, some sort of baseline, and how they correlate to that overall business objective that we're trying to achieve, we don't know how to scale for an event like this. We don't know if horizontal scaling is going to do us any good. We don't know how to re-architect individual pieces of that system, or potentially the entire system, to squeeze more out of one or more parts of it. Most importantly, and because we're here at Next, if we don't know those baselines, we don't know how to work with our partners like Google to actually make sure that we have those resources available to us. No pressure, right? No pressure. The bottom line, though, is that we understand what our metrics are, and then we actually have to use them. It's not enough to just have them. Because metrics ultimately end up informing change, right? With a site as large and as complex as Target.com, it can be hard to track all of the individual moving pieces. Individual teams, they run their own performance tests and gather their own metrics. We provide some of those metrics for them, some aggregated, et cetera, but the overall system is really what's selling socks. And thankfully, Target.com has a dedicated performance engineering team in order to help make that happen. We run weekly load tests against the site, gather metrics, correlate performance against the changes that we know occurred, all important, all also part of Carl's slides. And we're trying to understand with some level of certainty exactly how the site will perform from week to week. Going into peak season, we start running those performance tests twice a week. And even closer to peak season, we will start running failure tests at least once a month, and then over the course of the year, once a month again, more frequently during peak. So here's a controversial statement for you. It's okay to not to have comprehensive coverage of all of the pieces of a complex system. It's okay to not have comprehensive coverage. Carl doesn't want to tell you that. Google probably doesn't want to tell you that. But what is most important is knowing how the overall system is behaving, aligned with the business level objectives. So we make sure that our feedback loop is tight. We know what decisions we're making based on business metrics, and those business metrics help to inform reasonable architecture changes to make us better, faster, more resilient. Now, all of that said, there's always room for improvement, no matter how well you're performing, and sometimes there's no time like the present. I've talked about alignment on business metrics. Fine, we know what they are. We know how we're performing. We know where we can get to based on testing. We know where we want to get to based on predictions. And if you know all of this, you're already ready for Black Friday. It's not really about the event. The event just provides drama for the background. Last year, about a month before our peak season actually started in earnest, we decided that we needed to introduce a brand new aggregated caching service onto Target.com. Brand new, shiny, awesome. The goal was very, very simple. It needed to preserve the guest experience on Target.com by protecting some of the more monolithic services downstream. Now, we had clear evidence with our metrics that the downstream services were already operating at their peak performance, that they would very likely break under our predicted stress. And it was highly unlikely that we were going to squeeze more out of them. So it was really important to protect that downstream service, and one of the architectural patterns that Carl talked about was introducing a caching tier. And by some software development standards, this particular new service was still in its planning phase, still in its innovation phase on the evening of Wednesday, November 22nd, just before Thanksgiving. Yeah, it was risky. There were a lot of internal conversations about, should we really be doing this so close to our biggest moneymaker of the year? Lots of meetings to evaluate that, lots of meetings to back up confidence claims that we had. But the fact is that we could bring numbers to the table. We were confident we knew how that caching service was going to perform. We were confident that we knew that it was impacting our downstream services in a very positive way. And we knew what its breaking point was. We were kind of sure that we weren't going to hit that breaking point, but we knew what the breaking point was. Spoiler, we hit the breaking point. So that kind of brings to mind Carl's "don't rely on your caching tier." What's most important about that is that we would not have been able to make that decision without knowing what we knew and measuring what we were testing and making improvements and protecting ourselves and ultimately our guests. All right. Even after you know what you're capable of, it's still important to know your growth potential and prepare early. Our talks with Google about capacity planning already started. And some people inside Target might believe that 4 months is far too soon. But it's not always about CPU and disk. As Carl hinted at, you cannot forget about your API quotas and your rate limits. Last year, we were throwing so many last-minute requests at Google for certain types of resources that the quota and certain types of resources and quota increases that our strategic cloud engineer at Google said, quote, "You can't have any more if it has a transistor in it." Okay, wait a second, what doesn't have a transistor in it? Right, okay, he said it jokingly, at least maybe there would be a little laugh. I got one little chuckle, that's good. And then he followed up with jokes about needing to put on his armor to protect himself, to go pray to the capacity gods to make sure that he wouldn't get cut down. Now, look, side note, we did get the capacity we needed. He said that in jest. The story here is about throwing the requests at them so close to peak, to the point where they felt that they couldn't actually meet our expectations. Start early. From Google's point of view, I'm sure that all of those additional requests were extremely frustrating, right? My God, they're asking again. From our point of view, it looked like it had triggered an internal release of a new alpha feature for quota management across the organization, where you can swap quota from project to project within an org. Now, maybe that's entirely egotistical of us to think that we did that, and maybe we did, maybe we didn't, maybe it was planned, doesn't matter. Point is that when they flipped that switch and turned on that alpha feature, it unwound some of our rate limit request increases that had already been put into place. And I hope this isn't a secret, but some of them aren't changeable for non-platinum customers. Some of those rate limits you can't normally change unless you're at a certain service level with Google. Takes some convincing. I hope that's not too much of a secret there. But they destroyed those rate limits by accident. We didn't know. It's an alpha feature. And they broke our performance tests. No big deal, right? You run performance tests once a week, but we're 32 days away from Black Friday. All right, well, I'll leave it as an exercise to the listener here to kind of imagine what those conversations looked like inside of Target following that event. Vendor engagement is critical. Early vendor engagement is critical for both parties, not just you, but for Google as well, for your other vendors. And if you have the right kind of relationship with your vendor, maybe you can ask them for insight into when they're making changes on whatever services of theirs you're using. Things are always going to go wrong. You absolutely cannot prepare or plan for every possible contingency. You can, however, practice the plans you have contingencies for. Google recommends the wheel of misfortune around a tabletop. You pick a scenario, you play it out, you talk through it. We found that extremely useful the first time we did it. It helped us identify communications channels, who to talk to at what point, both internally and externally across the vendors, who to call in different situations. But over the last few years, we have learned internally that we'd rather just break stuff and see what happens on purpose. Yeah, so that's what we do. We do chaos testing. It's a term that we're borrowing from Netflix, that's fine, but we do chaos testing inside. Planned or automated, it doesn't matter. Introducing the chaos is what's important. So every other week for 2 to 3 weeks leading up to peak, and continuing less frequently after that, my team handcrafts scenarios to break critical or sensitive parts of our infrastructure on purpose. And then small groups that are not related to the planning will try to figure out what we broke, get in there, fix it, follow a playbook or two, and afterwards we have our retro. The rest of the team during that will watch because everybody ends up being on call at some point for our team. We have a retro, we have what worked, what didn't work, we update our playbooks, we go from there. Life is great. And in doing this, we have learned 3 big things that I want to call out. 1, you absolutely cannot cry wolf. At first, we didn't tell our app teams what we were doing. We didn't tell them that we were introducing manual chaos into their system, and they really didn't appreciate being pulled away from their other critical tasks. Don't cry wolf. Number 2, once you tell them, and it sounds obvious in retrospect, our customers talk to one another. Your customers talk to one another. Whoever your customers are, they talk to one another. Once we involved them, something very interesting started to happen. They got very into it, and then they started introducing their own twists and process twists to our chaos, introducing more chaos, and ultimately that unveiled private communication channels between them that we weren't previously aware of. But that also allowed us to take a peek at what they were talking about and make product improvements over time. And the third thing that hopefully chaos is going to do for you is help you recognize that you probably actually are ready for Black Friday if you've done all of this work. One of our scenarios involved taking down our service discovery services in a lab environment, that's fine. And in planning it, we thought it would be as easy as doing X. In reality, it took longer for us to take down than it did for the team that was following a playbook to bring it back up, because we had accidentally built in a whole bunch of resiliency that the system was already regenerating itself behind the scenes, and we had to break it in a way that would probably never actually happen in real life. You know, like an admin goes in and changes or removes a network route. Interesting. Anyway, I apologize. I have one more slide here that I'm going to leave up. If it works. I have to hit the not laser button in order for it to work. And I have one more slide here that has a whole bunch of bullet points. I have 15 seconds left on the clock. So I'm going to leave this here, As I want to bring Carl back up to wrap this up. I'll leave this here for a split second, and I'm happy to talk with folks afterwards. Carl?
Yep, so real quick, just a summary as we're at time, is remembering the 3 different stages we sort of covered and some of Ron's experiences going through that. I want to throw out that if you're interested in additional resources on this, the original site reliability book, of which the second sort of supplemental element is being released here at this conference. These are links for the book. It is publicly available at the URL listed. My particular team, the Solutions Architect team, develops a lot of solutions and planning processes for all kinds of different scenarios. The link is there. And then real quick follow-up. If you're interested in doing some DevOps type stuff, the Google Cloud Solution Architects team has a very interesting game-oriented scenario to try out your DevOps chops. And lastly, our networking team is giving out a really interesting poster for the Google network that you can order one at the URL posted on that link. So we're over a little bit. We really appreciate your attention. Thank you. And if you want to grab Ron or I afterwards, we're happy to sort of have some one-on-one conversations. Thank you, and have a great rest of your conference.